You guys, somebody just pointed out to me, and I'm sorry, could you check out how many pages are in here? Did a lot of typing. So I apologize for typing fast. But apparently, somewhere along the way last week when I was in my office on Friday or Thursday, 2 times 2 became 8. Sorry. There are 2 8s now, there should be 4s. Question number 2. Thanks for pointing that out, David. I appreciate it. So you guys take over. Any questions? Yes?
Well, I have a question about this quiz. Is this the...
Oh, the quiz.
Is this the one we just turned in, is that the 7th quiz or the 6th?
It is. Yes, number 7.
So the one you passed back is the 6th?
Yes. Yes. Oh, thank you, Dave.
And,
oh, by the way, I already typed the solutions to the quiz. I just didn't post them because I didn't collect it from you yet. But at the break or at the end of class, I'll post it real quick.
And so over the weekend, I read section 7.5 and 7.6, and I didn't quite understand the concepts you wanted us to learn, because I think in section 7, they were talking about using tables and other computer methods.
Yeah, and I just didn't.
So are we just doing those problems using the techniques we learned in the previous sections, or?
Yeah, I don't think this would be a very good test question. Here's a table of intervals. Use them. I just don't think that would be an appropriate question to ask in a test situation. And so that's why I did not emphasize it. I think this would be a good question. If I give you one of those integrals in that table in the back of the book, if I just give it to you in an exam situation, would you be able to verify it? I think that would be a good test question. I hope you agree.
Oh, I was just, when you say table, you mean like the reduction formula?
Yeah, and some of them aren't reduction formulas, they're just tables of integrals that you could use to evaluate inputs.
And just use trig or trig whatever to manipulate it.
I agree. The one in class I think I gave you an example of, it was a reduction formula. I think I used integration by parts, as I recall.
Yeah.
I don't remember the question.
Secant cube. Yeah, or secant to the power.
Oh, that's right, that's what it was, yeah. You guys ever heard of Omar Bradley? Nobody? Omar Bradley?
No.
Great general for the United States in World War II. He used to fly one of those lumbering DC-3s in the European theater of war. He got so bored being in the airplane all the time, but whenever they hit ground, he typically have a staff to scour the area and see if they could just find sheets of integrals he could evaluate on the airplane just to keep his mind busy. So it was recreation. I'm sorry, Brad.
Okay. So can you do number 69 from 7.4?
7469.
And then 7.5, can you do 23 and 28?
Why is that? Because of the weather or because of the example?
Because 69 is the one I was looking for.
Oh, I see your point. Gotcha. So do you guys think you can give me a show of hands? How many of you are actually caught up on the homework? Whoa, you're kidding. Really? Do you guys know what's happening this Thursday?
It's
Yeah,
4th of
nothing.
July.
4th of July, we have it all. So our exam's actually one day sooner than maybe anticipated.
So are we having a quiz tomorrow and then an exam the next day?
Gosh, I haven't thought about that. Yeah, I guess so. Yeah, treat tomorrow's quiz and practice for the exam. I hate to take quiz away from you guys. We're already at quiz number 7. That's really slick. I'd really like you guys to have a lot of quizzes under your belt before we end the summer session.
What about a take-home?
Yeah.
Or the long?
Instead of one tomorrow.
Oh, instead?
Yeah.
Oh, no,
Or we could have both.
Yeah,
Yeah,
or
can we have
both.
Or both. Both
Yeah, but you guys, it might be the case that I forget about take home. So if I do, just remind me Wednesday when you take the exam, hey, are you gonna post one? And if I had forgotten by then, I'll just make one up right there on the spot and create a hyperlink. No, I'm just such a busy week this week. I can see myself forgetting to write a take home. So tomorrow's quiz, not that I thought about it, just an interval of any type. You determine how to solve it. Without evaluating. So you guys check this example out. I know it's coming from a certain section, but wouldn't you guys agree that number one is a rational expression in integrand position? Number two, very clearly, I cannot make any quick, easy use of. And so I think immediately I'd succumb to the technique of partial fraction decomposition, PFD. Oh, thank you. I didn't catch that. I guess it wasn't hard to get. So everybody, if it's partial fraction decomposition, you know what? This isn't going to work. I think I need to slide it over a little bit. I anticipate needing all the room. And I do agree, you guys, that the technique of preference here certainly would be partial fraction decomposition, which means it is time for me to pull out my very first piece of scratch paper. I'm going to take my nifty little fraction. Well, not so little, is it? And break it up. So, what's next?
Why did you put ax plus b?
You saying I made a mistake?
Oh yeah,
How many?
a couple.
Yeah, I think I made a couple mistakes. Number one, that first fraction has a linear denominator, a denominator of degree 1, and the original rational expression, the integrand's position, was proper, so I think this fraction should be a proper one. And if the degree downstairs is 1, I think the degree upstairs is going to be at most 1 less than that, which is degree 0, which means if there is something there, it's just a constant. Secondly, I may not have made a mistake with this numerator, but I'll change my letters. I just think I need a third term, namely a fraction in which my denominator is a quadratic expression twice. My numerator is going to be, lost track of my alphabet, sorry. So you guys, instead of doing this, do you think I could do this? Listen to my choice of words carefully. Could I have just expanded this, looked at it as a polynomial expression of degree 4, written the fraction only once instead of twice with a numerator that was degree 3? Could I have done that? Yeah, I think I could. I think I could represent these two fractions as a single fraction. I think it makes my life more difficult. I like this denominator factored as such, but I certainly could have expanded out and rewritten it as one single fraction. However, I didn't, so let's just roll with it. I think it's my mathematical responsibility to come up with values for a through e, so I'm just going to clear fractions that equation. And then clearing fractions, that leaves me with this. X equals my a times the quadratic factor twice, plus my bx plus c times both that linear factor and the quadratic one. And finally, plus that last numerator times this time only the linear factor.
You forgot a square on the A.
Did I really? On which one, the first one?
Yep.
I most certainly did. I got to multiply it twice for that quadratic factor. And to start the process off, wouldn't it be a piece of cake just allow x to be 1?
Yeah.
And allowing x to be 1 allows me to drop out a lot of these terms. And if x is equal to 1, I clearly see that a is equal to 1/5, I think? No, 1/25.
Yeah.
You guys have double checked my arithmetic.
Yep.
Now, I'm kind of in trouble for the rest of them, so now I got to slow down. And you guys, in slowing down, I'm going to try to do something kind of lazy, like maybe look at coefficients of something special. Like for example,
B.
what do you mean by b though?
The x to the fourth terms, there's only two of them. Maybe a
Would-
zero.
Wouldn't it be a good idea to just kind of FOIL all that out so you can look at all the coefficients?
It would work. Matter of fact, Brad, that works every time.
Yeah.
I hate to do that myself because I make silly little arithmetical mistakes. So instead, to avoid those arithmetic mistakes, I have a tendency to just look at coefficients that are quick. Dave, bless you, Dave, I'm nervous. Because I think if I equate coefficients of x to the fourth, I've only got this one. Where would the b one come from?
bx times x, which gives you x squared, times the x squared, which gives you x to the fourth.
Now, I agree with that, but how do I come up with the x to the fourth term from the third group?
You don't.
You guys, that's what I'm saying, maybe this is the easiest approach. And I'm not being very cautious and blowing everything up. I'm just saying, glancing at the right-hand side, there are only two terms involving an x to the fourth. And I think equating coefficients of x to the fourth on the left-hand side to the coefficients I see on the right-hand side, which as a single coefficient would be a plus b. It just immediately tells you that b holds a value of the opposite of a. Now I'm actually going to get a little nervous. I think the rest of the coefficients might not pop out that quickly. So what's next? Somebody give me a hand with this.
I have a question.
Yes?
At this point, can you plug in A and B into that and just get rid of those?
You know, you really could and absorb them to whatever constants on the right-hand side, but I think that amounts to blowing everything up again and doing a lot of arithmetic. I am this lazy. If I were to look at constant terms next, then whenever I come across an A and B, I'll just slip it into that equation. For example, let's do just that. Let's look at constant terms. I think on the left-hand side, here's my constant. On the right-hand side, however, I think my constants become, oh, look at this, you guys, a 4a. Sir, do you see what I mean? I'm just putting in whatever I can. How about minus b, which in this case would be a plus 125.
Minus c, b is x.
Thank you very much. My goodness. I said minus c. I put in my b value. But what's left over? So say it again.
Minus 2c.
Yeah, if you could take into consideration that as a factor, I think we get another factor too. So I think we've got a minus 2c. Anything else?
E is negative e minus
Got it. I agree. So you guys, unfortunately with this equation, I'm kind of stuck. I can't solve for c and e just like that, but at least I can grab a couple more equations. Maybe I can get some involving c's and e's and solve the system. So let's keep running with this. Let's see if you and I can't generate, you guys pick one. What do we look at? I'll grab whatever you like.
X to the first.
If you want to look at x to the first power terms, I think if you were to multiply this garbage out,
Shouldn't we look at x to the third?
that's what I'm saying. It's entirely up to you. What do you want to look at?
Well, I would normally go fourth to third to second to first.
But it's easier to do it another way.
Yeah, I guess I don't know how to respond to that, Bradley. I mean, you can do it either way.
Alright.
I think depending on the situation, the numbers, one way might be easier than the other, but let's look at x terms. Looking at x terms, if I multiplied all this garbage out, don't look at the a. What would the x term be? Anybody? So what would that give me? I think give me an 8x, wouldn't it? And so I think I've got an 8x times a, the coefficient is just 8a. And the coefficient on the right of the x term then would involve a positive 8a, that'd be this. However, if I were to FOIL all this garbage out, I think from that collection I got a couple coefficients. So it could be a negative b plus c. Let me say that again. I said negative b plus c. Oh, maybe not. Everybody. I take that back. I didn't see this factor. My goodness. I do take it back. Since I'm multiplying all three of them out, where's my eraser? If I multiply these two beasts out, I get this. Excuse me.
If you plug in x cubed, you should get 4a plus b plus c.
So you're saying for the x cubes?
Yeah,
Can you say it one more time? I'm sorry, Brad.
4a plus b plus c.
Excuse me. But that's a coefficient of x cubed, so on the left-hand side, the coefficient of x cubed is such. That's a nice relationship because at least now I've got the values of A and B. And that would give me a 4/25 minus 1/25 plus C equals 0. But that certainly implies that C is equal to, is that a negative 3/25? Well, everybody, I've got my A, B, C. The only thing I'm missing are D's and E's. I've gone this far. So I've gone this far with the x's. Here's a coefficient of x from the first term. What about the coefficients of x in the second grouping?
Look, plus bx right there.
I don't know, is it? Because I think I get a negative 1 times bx.
Oh my god, sorry.
That's
I was
okay.
looking at the wrong thing.
But don't you guys agree I can get a coefficient of x by multiplying these two to these two? That could be a plus 2c, minus 2b. But I also get a coefficient of x by looking at this constant times my 2x, but that would just simply give me, hold it, that c is missing. That would give me a minus 2c. And finally, jeepers, there's a couple more, aren't there? I guess that gives me an e minus d. But you guys, it's not that bad because I do think I've got values for, at this stage of the game, b and c. I'll slip them in. Gee, this is going to work.
So the C would just cancel.
Oh, how nice, I didn't even notice that.
And you have E too, because now you can see.
If you do x squared, it's going to be 8a plus c plus d. It literally works out like every time you
Does it really?
decrease a
Is that nice?
coefficient, or decrease an exponent.
But you guys, here's my question. I promise I'll finish. Is this going to work?
Yeah.
I think dramatically. Look, I've already got one equation up here in terms of e's and c's. I found c, so I can find my e right away. But that means my next equation, the only unknown value is going to be my d. So this will definitely work, won't it?
Yeah.
Oh, but shoot, I never finished my sentence. Darn it. I'm equating coefficients of x on the left-hand side. Well, there's a 1 length right there. So let's finish. Let's finish the process. And Bradley, with your
Yes.
next equation, you can check.
Okay.
Since I've gone this far. I suppose this equation tells me if c is equal to that I've got c being, e being equal to, is it negative 10? You're right. It'd be negative 10, 25ths. I can't do it.
It should be positive 10 25ths.
Yeah, I'll check my signs. So that's positive. Yeah, I agree, it's positive.
Okay.
Now from this equation, okay, now it's getting too messy. I gotta rewrite that. So that last equation, that tells us that 1 is equal to my 8/25ths minus 2b plus e minus d. Now diving in, taking care of my arithmetic, is that going to give me a positive 20? Telling me that d is going to be equal to, negative 1/5?
Yes.
If you guys are double checking my arithmetic. And if you are, I think we're ready. I think we're ready to value the integral.
So wouldn't
Yes.
it be a good idea just to leave them in terms of 25ths, because then you could just pull out 1/25th from the entire integral?
Yeah, probably. I wasn't even looking that far ahead. I can't argue with that.
All right.
So everybody, rewriting my integral. I guess that gives me the integral of my a plus by bx plus c, but b was, help me you guys, where is it?
Negative 1/25.
Negative 1/25, thanks. And my c was negative 3/25. And finally, my e, oh, excuse me, I misspoke. My d was negative 1/5. And lastly, my e held a value of 2/5. Is it positive or negative 2?
Positive.
So you guys, how about some words in English? Just words. Easy?
Yes.
Yes.
What do I get?
Natural
Natural
logos.
law. Easy?
No.
Close, yeah, not quite that easy. Shoot, if it were only in the case that this were x minus 1, yes or no easy?
Yes.
Yeah, piece of cake, a use of. But now that I don't have a negative x minus 1, but a negative x minus 1 minus 2, with the minus 2 over stuff, what am I going to do next? I'll write it. Let's just see if we can play chess and look ahead.
I would,
With the negative 2 upstairs alone, what do you get?
I would do trig subs and
I
to
would
evaluate
complete
that.
square an x, and a trig sub will take care of business. Next, what do you think?
Split it up over the addition sign.
Yeah, I'd probably add my funky looking form of 0 here. Or you can even split up right now.
I was a little bit confused on the funky form of 0 with the x. with
You
the
could
whole
pull
line
out
squared
5.
Yeah,
You could
David,
pull out
I guess
5.
what you're saying worse, you're gonna just have to put a couple more steps in there. I probably would have shaved off a negative
Yeah.
5, so that I can make a quick, easy use of with the first integral. But what about the second one?
trig sub.
Yeah, maybe another trig sub would be the way to go. So can we put it all together? Putting it all together with the first integral, oh, piece of cake, and our deep, deep REM sleep, I'm not gonna worry about it. For the second integral, I might be writing too much, you might be skipping some of these steps. I think for the second integral, I'm gonna break up as such. Be honest, you guys. Is that okay? If it is okay, let's keep rolling with this. And that being the case, I'll rewrite the next integral as such. Oh, hold on, my arithmetic might be a little off. Did I mean this?
Do you just leave the numerators negative and not factor out the negative 1, just for your own purpose reasons, or is there?
Yeah, you know what? If you look carefully at the board, I'm not even that consistent. I mean, I pulled out of this one. I didn't out of the first one or the third one. I just don't even care. I don't even pay attention, to be honest.
Okay.
Well, you know what, you guys? I do think this makes life easy. Because I think that leaves you with 1/25 times my first term. Do you guys think we can just write? As, do you think we just write?
Plus 1
Minus.
minus 1/2
1/2.
of natural log of x squared plus 2x plus 2.
Say it again.
No absolute value.
Yeah, how about none? It's always positive. Minus, we have an exam this Wednesday, right? Oh, really? Minus 2 inverse tangent of the quantity
X plus 1.
x plus 1. Phew, good. Next. You guys are killing me.
That one
Negative 5
over 2.
X squared plus 2x. Plus
Yes, yes.
Oh, but I get a sign change.
Why?
Ooh.
Because I think basically I'm anti-differentiating 1 over u squared, which becomes a negative 1 over u.
But wait,
Yes, I'll wait.
so when you differentiate that, right, you're gonna get x, or 2x plus 2, so don't you have to pull out the 2 also, so wouldn't it be a 10 on the top?
Well, I think when I differentiate, bring the 2's down, they'll cancel with the 2 downstairs.
That works too.
I think it works just fine the way it is.
Okay.
David?
No, I got it.
And for the last one, okay, you guys, I can't walk this fast. I think for the last one, I gotta slow down a little bit. Here, I think I'm gonna commit to this particular substitution. I will let x plus 1 be equal to the tangent of theta, which means dx is equal to secant squared theta, d theta. And now I'm committing to that substitution. I'll pull my 15 out. I'm being honest, you guys. I didn't do it that far in my head. What is left over?
Cosine squared.
Yeah, I think it is just a cosine squared. That's what I'm coming up with.
So somewhere along the line, I think I made a mistake here. I put x plus 1 squared plus 4 in the denominator. I'm just
Oh,
checking
yeah,
to
maybe
make sure.
it's an arithmetic
I just,
issue.
yeah,
Might
that's
have
my
been
mistake.
changed.
Alright.
You guys, what am I to do next? Again, we got a quiz this Wednesday. What do you do next?
Half angle formula.
Yeah, your half angle, or maybe you call it your double angle identity. Some people refer to it as reduction identity. Whatever you call it. I think my next step is to get all that stuff. I'm gonna replace this with a 15 halves. Times the integral of, how'd that go? 1 plus
Cosine of
Cosine
2
of-
theta.
Two what?
twice that angle theta. Which of course, in the end, is gonna give me a 15 halves times theta. I've lost it. It's an x
Plus, yeah.
plus 1/2 times 15 halves times the sine of 2 theta.
She should change to just 15 over 2 times sine of theta cosine of theta.
I agree. So I guess I'm leasing with a positive. Oh, I'm running out of room. We said 15 halves.
Yeah,
Sine theta. Whoops. I said sine theta.
yeah.
When I say sine theta, I mean this. Times cosine theta. When I say cosine theta, I mean this. Do you guys agree? If I'm not being too sloppy. David, this is the one you and I were saying, looks like there's a numerical error in the back.
Yeah, but that 15 halves clears it up.
Oh, does it?
I lost the 15 halves somewhere.
Gotcha. Gotcha. Anyway, that helps. You mean this integral right here? Here's what I really did. Now, make sure I write down the correct thing. Okay.
No,
What?
because it was minus x minus 1.
Oh, yeah, you're right, I changed it, it was a minus x minus 1, but now if I pull out a negative 1/2, can you guys enjoy the pretty colors? In the sense that if I allow u to be everything in red, du is upstairs in purple. And so I think in the end, all I'm really anti-differentiating is 1 over my u. So I wrote as my natural log of u, it's just that I had that Lincoln coefficient up there. Yes, sir?
You lost me 2 steps from my final answer, basically where you have the 15 halves and
So from here to here.
yeah.
So number 1, I would simply anti-differentiate one with respect to theta, but that gives me theta. Now look at everything above my hand. I think that's another name for theta because if I solve for theta in this equation, I'm just taking the inverse tangent of those things. Sir, let me put an extra step. I won't change it here. So how about this? This one right here, if I anti-differentiate, gives me 15 halves times my theta. It's just that with this relationship up here, I think another name for theta is the inverse tangent of x plus 1. So in my head, I was merely replacing this theta, not that I wrote it down with that particular expression. Secondly, I was anti-differentiating the cosine of something, but I think that gives me the coefficient up front. Times my 1/2. Times cosine is the antiderivative. And I have to confess, this gave me a slight problem in that the angle's not a clean theta. So stop for a minute. Come back up here. Look at this relationship and identify what the heck this really says about theta if I embed theta in a right triangle. And if I embed theta in a right triangle, I think it tells me that its tangent is x plus 1 over 1. Which means my hypotenuse has a length that I can be expressed this way, algebraically speaking. And so now, sir, you can clearly see that all I'm doing after I evoke my double angle identity, I've got 2 times the sine of that angle theta times the cosine. And that's where those two came from. Be honest, do you see it?
Yes.
You just tell me if I need to erase and make more room to clarify. this on the board. Please attack me.
I'm confused about the negative 5x minus 5.
You mean where this one right here came from?
Well, how do you get from that to the one below it?
Ah, this easy. Watch me. And again, also, sir, all I'm really doing is changing colors. But check this out. If I rewrite what's inside the parentheses in red, you guys remember this is a negative 5x minus 5. But wouldn't it be nice to write it in purple this way? Because at least what you see in purple is a derivative of what you see in red. No, I lied. I changed it. Because it really should have been a negative 5x minus 5. But if I just pull out both a factor of negative 5 and a factor of 1/2, it makes it completely legal. That's what I started with. It's just that now what you see in red, since it has a derivative of what you see in purple, I'm basically anti-differentiating 1 over u squared. But that's anti-differentiate u to the negative 2. So I'll take the exponent, up it by 1 to negative 1, divide by the new exponent. I think anti-differentiate u to the negative 2 is negative u to the negative 1. Or shall I say, negative 1 over u? Or shall I say, negative 1 over that u? So I change signs. That's what sign change means. Is anti-differentiate u to the negative 2. Anybody else, please? I don't mind.
Wouldn't that become 5/4?
Unfortunately not, because think about it. If I'm really anti-differentiating u to the negative 2, up in the exponent by 1 gives me negative 1. So I'm divided by negative 1, not negative 2. Okay. All right, if nobody else, yikes. Look, that question is number 69. Maybe we can answer another question before the day is over. In section 67523, how did mine turn out in the homework set? Did you guys try this yet?
Good.
Brad, one person?
Yeah, yeah.
Number 10 on the homework set.
I'll do whatever you like, just for mine.
So if we can only do one of these, 28 would be the one I need more help with.
Oh, that looks so nice.
So I'm assuming on test you give us a shorter one than 69?
Nah, he'll give you the full 2 hours. Figure it out. So you guys, I'm really stalling on this one. I just don't know what to say out loud because I'm in front of the entire class. There are a couple different approaches. What did you do? But Brad, you asked, where did you start?
Oh, I think I looked that up.
Because I was thinking you probably either apply to U-sub first.
Yeah, I think I did a U-sub because the inverse cosine is something that I can, well, I did a U-sub for root x first.
No, that's what I meant.
Yeah, and then I think I did a second U-sub after that.
Oh, did you
Or
really?
no, I think I did UV after that.
Yeah, that's what I was thinking.
Yeah.
Or you could have dove in a U-sub, integration by parts first.
Yeah.
It's up to you.
I have a question that's been bugging me about the way these are written. Is cosine inverse x the same as 1 over cosine?
No. And that's why this is horrible notation. I think whenever you and I use a superscript -1, I take my words back, I misspoke. Often, when we use superscript -1, it's interpreted as an exponent. Certainly when you see 2 to the -1 power, you want to think of that as 1 over 2 to the positive 1 power. Because the superscript is being attributed to a number. If I have x to the -1 power, I think you have no choice. You have to interpret that as 1 over x because that superscript -1 is a superscript for a variable and that represents a real number. If I had f of x raised to the -1 power, here too, I think you have no choice but to interpret that -1 as an exponent because what's that a superscript to? Well, f of x. But f of x is the output of a function. And therefore, this is gonna be interpreted this way. Absolutely not. I am 100% wrong. Here's why. Here's a superscript attributed to the letter f, which does not represent a variable. It's a process, it's a function. And so I think here, this is really referring to the inverse of my function f. And likewise here, when it comes to the cosine superscript -1 junk, here it chooses that -1 is a superscript for a function's name, COS. I don't think I'm allowed to interpret it this way. But this is a big point, this is a huge point. You gotta distinguish between f of x and f. I think f of x and f are definitely not the same thing. Think of f as a function, a process. In my kitchen, it's a bread machine. And I've got an input, among others, called flour. But if f is a bread machine, then what's going to be the corresponding output? If it's f of x, what's f of x represent in my kitchen? The loaf of bread. Do you see how the loaf of bread and the bread machine are completely different entities? And so that's why I'm saying f and f inverse, I misspoke. That's what I'm saying. F superscript -1 cannot be interpreted as an exponent because f's not a variable. It's a process.
Okay, but cosine race like the third.
I know, I knew you were going to say that. Now you're saying we're contradicting ourselves now because when you see COS superscript 2 of x, we interpret that, no tricks, as this. I agree. We violated that one instance. When that exponent, or excuse me, when that superscript n is anything but -1, it's just shorthand notation for raising the output of the function to a certain power.
Yeah, why did they change it from arcsine?
I think it's easier to write.
Okay.
This is why so many people like to refer to COS superscript -1 of x as the arc cosine of x, just to remove the ambiguity with the notation.
What does the arc represent?
It represents that. It's another way of referring to the inverse cosine function.
When I saw the cosine -1x, I had no idea what that meant, because I was so, when I grew up, it was all arc cosine, arctan.
Is that the only way you saw it when you were raised mathematically? Really?
I'm old.
There are a lot of teachers here that write it like that
You're not older than me.
instead.
So Bradley, you're saying a lot of us actually use the ARC notation?
Yeah,
even
Professor
C1.
Trong and Professor Buchwald write it like that.
So you guys, do you think we can get started on this?
Yeah.
Let's dive in. I'm going to do what Brad suggested. He's saying commit to Yusuf first. And if I were to commit to Yusuf, I think it's a good choice because I see root x and 1 over root x is all over the place. And if I allow u to be equal to root x, hang in the consequence of my actions, here's the relationship between du and dx. I'll commit. Does that merely give me this?